Hello, and in this video I'm going to be talking about how to compare the explained variance of two or more regression models in SAS. Now, I've already done a video on hierarchical regression, so this video isn't going to be on hierarchical regression specifically, but just to give a bit of background, in hierarchical regression, what we do is we have a number of predictor or explanatory variables that we're trying to predict a dependent variable, but instead of just stuffing all the variables in at once and seeing what comes out, we have some theoretical reason to believe that some variables are definitely going to predict the outcome, so we stick those in first, and then we stick other variables in as blocks to see if they can explain any additional variance above and apart from what's already been explained. So I've already got videos on hierarchical regression in general, but we're going to be looking at specifically in SAS. How do we get the statistic of, is there an increase in the amount of explained variance comparing the first model with the second model? So it's really about how to compare the models we're going to be looking at in this video, because if you've used other statistical packages to do this, it's a bit different than the way you might think. So and there's no way to do hierarchical regression any other way in SAS. So you create the two models and then add in this statement to compare the models. So with that said, let's look at our example. We've got data set open here, which we're predicting theory of mind performance from age, which is what we're going to have in the first block, just the age predictor, actually, and then our second predictive block is going to include some novel ideas of what might predict theory of mind. That's mother's mental state reasoning and the amount of eye contact made. Now, if you have one variable that you include in a block, it's just gonna be the same as testing the significance of that individual predictor in the individual model. So if you're gonna do a hierarchical regression, you have to add more than one predictor if you do when you do an additional block, because otherwise there's no point in doing that. If you just got one predictor, you might as well just put it into the model by default. So anyway, our theoretical idea here is that in the first block we're gonna put in what we know predicts theory of mind, which is age, at least in the classic sense, and then as a second block we're gonna add in mental state reasoning and eye contact to see if they can explain any additional variance above and apart from what's already been explained. So let's go over to our code. So if you've seen the other videos, what we're going to do is just run the regression procedure. So proc reg, I'm going to say our data is in the object called data. Something that a lot of people don't know about SAS is that you can, if you have multiple models, because what we're going to do is create two models and then work out the difference between them. If you have multiple models, you can actually label them on the line that you write them. So for our first line, we're going to say it's the base model because it just includes age, and we're going to say for that model that it's going to be model predicting theory of mind from age. And I'm also going to ask us an extra option for the R square for this model, because what this significance is actually going to be doing. It's telling us if there's a significant improvement as a result of those two predictors. But what it's doing conceptually is telling us whether there's a significant increase in R square, or the amount of explained variance. So we need to know what the R square is so we can know what it is testing. I'm just going to copy that because it's hierarchical. Our full model wants to include all the effects of our base model. So instead of calling it base, we're going to call it full. And this time we're just going to add in our other predictors. So maternal mental state reasoning and eye contact. And that would tell us if both of these models are significant predictors of our outcome, but we don't want to know if they're significant predictors overall. We want to know if these two variables, or the second model, represents a significant increase in explained variance above and beyond what we already had with age. So to do that, this is the critical part of this video. We're gonna do that with a test statement. I'm going to say what variables we don't. We're not going to say test whether this increase is significant. What we're actually going to do is say when these variables are equal to 0, is there a reduction in the explained variance? So in terms of specifying it in SAS, you're doing it backwards. You're saying is there less variance explain when these two predictors aren't included. So the two predictors that aren't included in our second model are maternal mental state reasoning. So just say test MSSR. I'm going to say if that equals 0, but there's another predictor we want to say equals 0. So I'm going to say if eye contact also equals 0, would that cause a significant reduction in the amount of explained variance? Because if getting rid of them causes a significant reduction in explained variance, then they must be explaining unique variance. So this is the critical statement right here. You have to specify both models, but then you have to test whether removing the predictors that are in your fuller model actually causes a reduction in explained variance. So with all that specified, we're going to select all that and hit run, and we should get some output. So we see our first model was a significant predictor of our outcome, and that's no surprise, because as you should always do in regression, we had a strong theoretical reason to believe that predictor would predict the outcome. So but what we're actually interested in is our second model, and that also predict the outcome, but our first model explained an awful lot of variance. So since it's got the same predictors in it, that's hardly surprising. What we actually want to look at in this case is this box here. This is going to tell us if there was a significant increase in amount of variance based on the second model. And notice that it says test here, test 1. It's coming from that test statement that we put, and see it says test 1 because you can test the prediction or the unique variance explained by as many boxes you want. You just have to make sure they're in your model and then put them in a test statement. So we see that although the second model explained additional variance, it did not explain any, or although it explained variance in the outcome, it did not explain any additional variance. That's a very non-significant result. From what I think it was. So that was how to do the hierarchical bit of hierarchical regression in SAS. The next thing I should mention is that we see here that it doesn't give us a change in R square like we have in some other packages like a SPSS. This is the same data in SPSS, and it gives us a, as well as that significance test, and you see we get the same result, but as well as that significance test we get a change in R square, so we know what's actually being tested. Well, we don't get a change in R square here, but because we have the two R square values, it's a simple enough matter to take the R square for the second model, because R square nearly always increases, as we see here, and subtract it from the first model. So the R square of our fuller model was 0.9496, and the R square of the first model was 0.9399. And if we open a calculator and substitute in those values, .9496 minus 0.9399, we see we get 0.0097, so it explained hardly any additional variance, and it's hardly surprising then that that's so non-significant. And indeed, if we look back at the SPSS output we saw earlier, that value of 0.001 in terms of additional explained variance is the same as we get here. So that was show of how to do the hierarchical bit of hierarchical regression in SAS, and specifically how to work out the unique prediction of additional predictors that you add in. So hope that was useful. Thanks for watching. Bye bye.